Okay, so let's look at a couple more laws about the sum rule for derivatives. Now, all the sum rule says is that if you have two functions, let's say you've got two functions, f of x and g of x, and let's say you're either adding those functions or subtracting those functions, and let's say that you want to find the derivative of that sum. Well, what the sum rule says is that you can basically take the derivative of the first one and then simply add or subtract whatever it is that you're doing the derivative of the second one. So, okay. Well, let's put this to use with all our other ones. Let's say, for example, you want to find the derivative of square root of x plus x to the third. Okay. Well, we can do that. That's no problem. What the sum rule tells us is that we can split this guy up. We can split this up into the derivative of the square root of x, the first function, and then plus the derivative of the second function, which is x to the third. And then we would just use the power rule on each one of these. So this guy, for example, the first one's the derivative of square root of x. Remember I told you guys you should memorize this one. This is just 1 over 2 square root of x. And then plus, oh, bring down the hammer, 3x squared. And that's it. That's the sum law. Now, another very useful law is called the constant multiple rule. And so what the constant multiple rule says is that if you're getting the derivative of a function that's made up of a constant times a function, so as some examples that I can kind of give you is, for example, if you have 3x to the fifth, or 7x squared, or 8 times square root of x. So this is all a constant times a function, a constant times a function, constant times a function. So that's what we mean by these guys. So this is the constant part, and this is the function. So what the constant multiple rule says is that what you can do is you can leave the constant out of it and then multiply by the derivative of the function. So let's do an example. Let's say I have, for example, I want to find the derivative of the function 5x to the fourth. Okay, so I already know that how to find the derivative of x to the fourth. Now here I have a constant multiplying it. So what I'm going to do is I'm going to leave the 5 alone, and I'm going to multiply that. Now I'm going to write this longhand the first time. We're not going to do this later when we get better. But so what the constant multiple rule says is that you can leave the constant out of it and then just find the derivative of x to the fourth. Now the derivative of x to the fourth, well, that you can use your fantastic hammer rule. So the derivative of this guy is 4x to the third, right? Let's bring this guy down, subtract 1. So what I get then is this is equal to 5 times 4x to the third, which is simply equal to 20x to the third. Okay, now, a simpler way of looking at this is you don't have to do, of course, all of these steps. And remember, this only works if this guy is a constant. It doesn't work with the product of two functions. We have a different situation for that later. Notice that if you forget about this guy for a second and you just use the power rule with this guy, you bring this guy down and you multiply that 4 times the 5, you get 20, and then you subtract 1. So you can jump from this step all the way over to that step as you get better. Let's look at another example. Let's do another example. Let's say we want to find the derivative of a fraction. Now, whoa, getting crazy. Let's say it's 2x cubed minus 4x squared plus 7 over square root of x. Now, first off, you might be tempted to go, hey, let's just get the derivative of this guy, this guy, this guy, and this guy using the sum rule and constant multiple rule. And the big answer is no. You cannot do that. Okay, so I'm going to show this later, but the derivative of a quotient is not equal to the derivative of the top over the derivative of the bottom. This is not true at all. And as a little test, try this. Try just a simple example. Try finding this. I'm going to leave as a little mini homework. Find the derivative of the top, the derivative of the bottom, and then divide it. And then try dividing first and then get the derivative. See if you get the same thing. And you'll see that you don't. But anyways, back to our problem. So how do we do this? Well, check this out. What if you use a little teeny bit of algebra first, and you go, hey, well, I can split this up by turning this into a little fraction, 3 fractions, all over square root of x. So just use your basic laws for square root of x. And then you can simplify these. Now actually, let me, instead of doing over square root of x, let me do it over x to the 1/2. So to make it a little easier to simplify. So each one of these I'm just going to write as x to the 1/2 over each one. And so then what this becomes is this is the derivative of this when you divide these. Well, you subtract the exponents, so you would get 2x3 is equal to 6/2. So 6/2 minus 1/2 is 5/2 minus 4x to the 2 minus 1/2 is 3/2, and then plus 7. This x to the 1/2, you bring it up, and this is x to the negative 1/2. Okay. And then you can bust out with your rules. You have your hammer rule, bam, bam, bam. So when I get the derivative of this guy, this is equal to 5/2 times 2, which is just 5. X to the 5/2 minus 1 is going to be 3/2 minus 3/2 times 4, that's equal to 6. X to the 1/2. And then negative 1/2 times 7, that's negative 7. X to the negative 3/2. Sorry. And then this guy, you can just, of course, bring it down as x to the positive 3/2. And so then in the end you would have 5x to the 3/2 minus 6x to the 1/2 minus 7 over x to the 3/2. And that's it. That's all she wrote.